I'm Sophia Shoemaker. You can find me at Wise Cobbler on Twitter. I work as a freelancer, and one of the companies I work for is called fullstack.io. We write lots of tech books, including these two, Full Stack React and Full Stack React Native. You can find both of these books at fullstackreact.com. We're running a little long on time, so hopefully I'll get you out on time. I have a live demo. If it crashes and burns, you all get out on time for lunch. So before I get into the technical side of my talk, I wanted to give a little bit of background. For various social, political, economic reasons, there are large numbers of orphanages in many regions in Africa. For example, in Uganda in 1992, there were 2,900, and in 2013, there were 50,000. So governments have begun to crack down on some of these orphanages that are not, in fact, really helping children at all, and in some cases abusing them. Some of them are not great places. They have shut down many of them and suspended or banned international adoptions. This last year I've been rebuilding an application for an organization called Kaime. They are working with orphanages and the government in Ghana. They want to get these children out of the orphanages and back with their families. A lot of times these children have parents or other extended family members still alive, and Kaime works to reunite these children with their relatives. The application I built for them allows them to collect data and generate reports based on the data. So the first iteration of the project I built, I used PHP and Laravel. Any PHP developers out there? So this worked fine. PHP is fine. But as a team, I've moved past that. As the team started to use it more, it was getting frustrating for them because their internet connection is limited. And every page load was requiring a round trip to the server, which when your internet is slow is not great. And actually, when I was checking into the hotel for the conference, one of the hotel receptionists mentioned that a few weeks ago, the entire internet in the hotel had gone down and they weren't able to check anyone in or process credit cards. So even in, a well-developed nation like America, the internet can not work. And so building an application that works offline can be useful, even in places like Salt Lake City. So the tech stack, I used MySQL, and the database structure was fine. I didn't need to change anything about that. So I focused on the server-side code and the front end. And I used AWS Lambda on the back end. And I won't go into too much details about AWS Lambda, but I will say that switching from an EC2 instance on AWS to AWS Lambda significantly reduced the costs for Kaime, which when you're a nonprofit is, pretty critical. So they're essentially just paying for the database because Lambda is so cheap. Okay, so going offline with React. Adi Asmani has written a really great 6-part tutorial on creating progressive web apps with React, which I really recommend. I use this tutorial as the starting point for the journey of creating this offline application. So what is a progressive web app? There's quite a few features of a progressive web app. I'm just going to cover a few of them that are relevant to the application that I built. This isn't a comprehensive list, but these are the ones that are relevant. It's progressive, so it works for every user regardless of browser choice. It's responsive, so it fits desktop, mobile, tablet. It's connectivity independent, which is what the bulk of my talk is going to be about. So it's enhanced with service workers to work offline on low quality networks. And then it's safe. It's served via HTTPS to ensure content is served securely. So one of the first things you can do to improve your web application is use a tool called Lighthouse. And if you're not familiar with this tool, it allows you to do an audit on your web application and see where you can improve in performance, accessibility, and just progressive web applications in general, it'll give you some really good insight. And I did this on my application to make sure it was all kosher. Okay, so in order to make any web application accessible offline, you have to make use of service workers. Service workers are JavaScript files that allow you to cache resources, such as other JavaScript files and CSS that can then be available offline. Service workers only run over HTTPS and make use of promises. So let's take a look at how to implement them. There are 3 stages in the lifecycle of a service worker: the registration phase, the installation phase, and the activation phase. So to register a service worker, we'll have to add some code that looks like this. And this outer block here detects whether or not service workers are supported. You don't want to register, you can't register a service worker if it's not supported. The register function registers a service worker, which is just a JavaScript file in our application. We have a then and a catch chain to handle what happens when the promise is either resolved or rejected. So in the installation phase, the assets are actually cached. To install a service worker, we have to add some code that looks like this. First, we add an event handler on the install event. Then we add a wait until method on the event. This holds the service worker in the installing phase until everything is finished. Inside the wait until, the cache's .open method is called to create a new cache called v1, which will be v1 of the site's resources. So if your service worker has been installed previously, and then there's a new version of the worker available, like you've updated your application and you have new assets that need to be cached, the new version is installed in the background, but it's not activated yet. So in the code here, you'll notice that it's the same install code that I showed in the previous slides, but we've renamed our cache, so now it's a v2, meaning that we have new assets that we want to install. So it's only activated when there are no longer any pages loaded that are still using the old service worker. As soon as the no more pages are loaded, the new service worker activates. So the cool thing is, if you use Create React App, it does it all for free, so you don't have to do it. Still good to know how it all works. So another aspect of this project that was really critical is actually determining when the user was online or offline. The navigator.online property returns the online status of the browser, with true meaning online and false meaning offline. So there's some gotchas with using it, but in general, it's a pretty reliable way to detect whether the user is online or offline. So in the application, I started to notice a lot of code that looked like this, a bunch of if-else's all over the place. And I know Michael said dries chafes, but in this situation, I wanted to make my code a little more maintainable. So I created a function that took 2 callbacks as parameters, an online callback and an offline callback. So this way I could customize what happens when a user is offline versus online. And I combined this functionality with another functionality called local storage to determine how and when to store data. So when the user's offline, how do we store the data that's getting created and updated, right? We can't make requests to the server. We can't send stuff to be saved to the database. And there's a few options for storing data offline, but after researching all the different options out there, I decided to go with using local storage because it was the easiest solution for my use case. So local storage is a property on the window object, and the data is stored, the stored data, is saved across browser sessions. It's a key value store that has set item, get item, and remove item methods on it. Only strings can be stored in local storage. So if you want to store anything other than a string, like an object, you have to turn your data into a string. One caveat is that while storage limits for local storage are larger than something like using cookies, you can't store gigabytes of data unless the user specifically allows it for a domain. So typically the local storage limit is around 5 to 10 megabytes. So here's an example of how I use local storage in the Kaime application. Since I was frequently dealing with JSON objects, I'd use the JSON.stringify method to turn the JSON objects to strings. When I pulled the data out of local storage, I parse the strings again and turn them back into JSON objects. Okay, hopefully this works well. Sorry. Okay, so this is what the Time8 application looks like. Let me filter by and get some test data. So there's a couple of records here that are test records. So if you see over here, there is a black button, and if I click that black button, that actually saves the. It's a little slow because the Lambda needs some time to warm up. It will download the user's or the record and save it in local storage. So now that black button is grayed out because it is saved in local storage. So I'll just save another one. Okay, and so then if I turn off Wi-Fi, so there's a little indicator here that says it's offline. So now you don't see any of the records that are only available online. So if I go in here and edit, let's see, I'll just remove this. Hometown, Redwood City. And then go back here, you'll see that this one is highlighted red, which indicates that there has been data saved offline. And then if I go back online, it refreshes, and then if you search here, if I click on the edit button here, there's this screen that allows you to upload the data offline. Or you can alternatively, in general, they would upload the offline data, but if for some reason they didn't want to upload the offline data, the data that was saved offline, they can just grab the data that was saved on the server. So, yeah, that's how it all works. So this is how the data is actually saved. So you can see that I use my online-offline function, and when I'm online, I have a flag that says that it was saved online, this remote, and then when it was saved offline, I flag it as optimistic, so that I know that it has been saved offline and that the functionality needs to change. And then this is the get orphan data. This is how I retrieve the data, and depending on whether the user's online or offline, and whether there's been optimistic update that has happened offline, I grab the data and use it accordingly. Oh, okay. So this is a Time8 team in Ghana. Actually, let me go back to. Hopefully, this works. Hold on. Let me get the. Okay. And thinking about how to build this application, I knew I could impose a few constraints on how the offline interactions work. The team in Ghana is very small. There's just 4 people working together to gather information about the children, so it was a lot easier to manage how the users would be allowed to use the application. I knew that there would not be a risk of a user potentially editing a child's record online and somebody else editing the same record offline because they all work together. Obviously, if the team scaled up, I'd have to rethink my approach, and there would be different constraints. For example, maybe as the number of users scaled up, I'd probably have to assign a child's record to a particular user to ensure that the record data would not get overwritten. So in this process, there were quite a few challenges and frustrations that came with this project. Dealing with offline applications is not an easy task. There were lots of hair-pulling moments. So at one point, the team in Ghana was having some issues with the application, and I couldn't reproduce the issue on my end. So we had a Skype call, and they literally had to hold a laptop up that was offline that was experiencing the issue, and I had them like inspecting elements and opening Chrome DevTools because you can't do a screen share with a computer that's offline. So the time difference, the language barriers, and just a variety of different issues like made for some really interesting challenges and required a lot of patience both on my end and their end. If something wasn't working, I'm sorry, I'll fix it. We're still working out some bugs, but in general, it's a much better user experience. And then finally, I just want to share one last thing that I've seen floating around the internet in a few places. It's the Japanese concept of ikigai. So everyone, according to Japanese culture, has an ikigai. I hope I'm saying that right. If somebody's Japanese and can come correct me, please come talk to me afterward. So discovering one's ikigai brings satisfaction and meaning to life. When you combine these 4 elements, what you love doing, what the world needs, what you can be paid for, and what you're good at, you can find your sense of purpose, your ikigai. So for me, this project has been an ikigai experience. I've loved stretching my React skills and feeling like this project provided more value to the world than just some of the other projects that I worked on. Just like Caroline suggested yesterday about civic hacking and building things to help others. Like, I hope you all can find a way to use React in a helpful and useful way that go beyond the typical ways of thinking about how we create web applications. I hope you can all find your ikigai experience with React. So thanks.